Magandang araw at welcome back sa ating channel. Ang topic natin sa video na ito ay ang tungkol sa balanced three-phase phasor diagrams at complex numbers. So ituturo ko sa inyo sa video na ito kung paano mag-drawing or mag-construct ng phasor diagrams at kung paano mag-calculate ng line-to-line voltage at line current using complex numbers. Pero bago tayo magsimula ay gusto ko munang i-shoutout sila Jet Mark Dultra at Mark Opus. Maraming salamat sa inyong pagsuporta. At inaanyayahan ko na rin yung mga hindi pa nakasubscribe na i-click nyo na po yung like and subscribe button at isama nyo na rin yung notification bell para ma-notify kayo sa mga susunod ko pang video. Maraming salamat po at umpisahan na natin. Sa ating previous video tungkol sa three-phase power systems or balanced three-phase power systems, na-determine natin na ang ating line current sa three-phase Y-connected system is equal to phase current. At yung atin namang line-to-line voltage is equal to square root of 3 times the phase voltage and leading by 30 degrees. So, ibig sabihin, kung ano yung angle ng ating reference phase voltage plus 30 degrees, ayun yung magiging angle ng ating line-to-line voltage. So, sa three-phase power system, sa balanced three-phase power systems, ang ating voltage magnitudes ay laging equal sa bawat phases, pero separated by 120 degrees. Okay? So kasi meron tayong 360 degrees sa ating polar plane and then we have three phases. So 120 degrees apart yung ating phases. Yung ating angle or yung ating voltages sa bawat phases is 120 degrees apart. Okay? So kung meron tayong phase voltage, let's say ang phase voltage natin is, let's say, VAN, VBN, at BCN. So, kung ang ating voltage VAN ay ilalagay natin sa reference na 0 degrees. So, igagamitin natin yung red sa ating phase A kasi na very common naman sa color coding ng ating mga phases. Yung A is red, B is yellow, and C is blue. So, phase ABC, RYB. So, gagamitin natin yung red. So, ilalagay natin yung ating phase VAN, voltage VAN, dito sa ating 0 degrees. So, VAN at 0 degrees. So, ayan ang magiging reference natin. And then, dahil 120 degrees apart yung ating voltages, so yung ating voltage BN is nandito. Okay, so that is VBN, which is negative 120 degrees. Dahil gagamitin natin dito is yung positive phase sequence. So i-take note natin dito, positive phase sequence. Kasi pagdating natin sa symmetrical components, meron tayong positive phase sequence, negative phase sequence, at saka zero phase sequence. Okay, so dito sa analysis na to, ang gagamitin natin is positive phase sequence. Okay, and then pagdating naman sa ating voltage VCN, gagamitin natin yung blue. So, 120 degrees apart na naman, so banda rito. Okay, so kung ito ay negative 120, ito naman ay positive 120. So, VCN, which is equal to, with an angle of, or positive rather, positive 120 degrees. So, ito is 120. So, itong ano na to, itong angle between AN and BN is 120 degrees. At ito is 120 rin. Okay? So, i-determine muna natin yung ating voltage, line-to-line voltage using phasor diagram. So, meron tayong formula na, let's say, kunin natin yung VAB. So, voltage AB is equal to VAN minus VBN. And then, yung ating VBC, which is yung voltage between phase A and B and C rather, is equal to VBN minus VCN. And lastly, meron tayong formula para sa voltage VCA, which is equal to VCN minus VAN. So, ayan yung ating magiging formula pagdating sa calculation ng ating line-to-line voltage using complex number. So, kung mapapansin ninyo, yung ating line-to-line voltage is the difference of two phase voltages. So, pagka nagko-combine tayo ng phasors, ang ginagawa natin is, yung second phasor, yung tail ng second phasor is idinudugtong natin sa head ng unang phasor. Pero, we should take note of the sign. Let's say dito, kung positive itong sign na to, kukunin din natin yung phasor na yon and then idudugtong lang natin siya with the same direction. Pero kung negative yung sign, kukunin natin yung opposite direction or rotate natin ng 180 degrees. So, say for example dito sa ating VAB, which is BAN minus BBN. So, ang VAN natin is yung reference, ayun yung ating reference phase voltage, which is in nasa 0. So, as is yan. And then, yung BBN natin is nandito. So, which is at negative 120. So, ang gagawin natin dyan is, kukunin natin tong phasor na to, and then, idudugtong natin yung tail nyan sa head ng una, pero, iti-take note natin yung ating direction. Since negative ang sign nyan, so imbis na papunta rito, papunta doon sa kabilang direction yung arrow natin. So, magiging ganito. Okay? So, yung resulting vector nyan is yung from tail ng unang vector papunta sa head ng pangalawang vector or phasor. So, ito yung magiging resulting phasor. Okay? So, yan yung ating VAB. So, ang angle niyan is 30 degrees. Kasi, ang reference natin is at 0 and then lagi daw ahead by 30 degrees. So, ang angle niyan is magiging 30 degrees. Okay? So, 30 degrees. Ang value nito ng VAB is equal to square root of 3 times VAN. Okay? So, meron na tayong phasor sa voltage AB. Next is yung ating VBC, which is equal to VBN minus VCN. So, ang ating VBN is yung ating magiging reference. So, as is itong VBN dito, and then idudugtong natin yung negative VCN. So, ang VCN natin is itong phasor na to, which is papunta doon. Idudugtong natin ngayon yan. Kukunin natin yan. Dudugtong natin, pero dahil negative yung VCN, ang direction niya is, imbis na pag ganito, is pag ganito. Okay? Okay. So, ayan yung magiging direction. And then, same thing, kanina, ang magiging phasor natin is from, so, ang magiging direction yan is ganyan. So, ang magiging phasor natin is from tail ng una, papunta sa head ng pangalawa, which is ito. Okay? So, ito yung ating magiging BBC, which is equal to BBC, or yung magnitude ng BBC, and dahil yung ating reference is at negative 120, and then leading by 30 yung ating line-to-line voltage, so, negative 120 plus 30, so, magiging negative 90. Okay? So, ito pala is ibalik natin sa blue. Okay, para malinaw. Okay, next is yung ating VCN. So, ang VCA rather. So, yung VCA is equal to VCN, which is ayun yung magiging reference natin, minus VAN. So, ang CN natin is nandito, and then yung VAN is yan, nandun. So, dahil minus yung ating operation or negative yung sign ng VAN, idudugtong natin yan but with the opposite direction. Okay? So, kung ito yan, kung ito yung ating VAN, imbis na dito natin idudugtong, dahil negative yung direction, mapupunta yung ating arrow doon, yung VAN. And then, same thing, yung resulting vector or yung phasor is from the tail or from the origin to the head of the next one, or to the head of the second one. So ito yung ating magiging BCA. So BCA is equal to the magnitude of BCA, which is equal to square root of 3 times BAN, and with an angle of 150 kasi leading by 30 daw yung ating line to line. So dahil ito ay 120 plus 30, so ito is 150. So isulat natin yan. Itong angle na to is 150. Itong angle na to is 30. At itong angle na to is negative 90 degrees. Okay? So from the phasor diagrams, alam na natin yung ating magiging angle. Pero hindi natin alam yung magnitude. Makakompute natin yung magnitude na yan pag in-apply natin tong formula sa ating line-to-line voltage na square root of 3 times the phase voltage. Okay? So, mag-solve naman tayo ng example ng ating calculation ng line-to-line voltage from the phase voltages using complex numbers. And then, makikita natin yung relationship ng line-to-line at saka yung phase voltages base sa ating results, at pati yung angle is makukuha natin base sa calculation using complex numbers. So let's say sabihin natin na gamitin natin yung nominal voltage na ginagamit natin sa mga bahay o sa mga opisina na 230 volts sa phase voltage. Kasi normally sa mga three-phase supply, ang ating line to line is 400 at ang ating single phase is 230. So dinidrive natin yan from the neutral. Okay? So let's say VAN, let's say meron tayong VAN is equal to 230 volts at 0 degrees. Ayan yung ating reference. And then VBN is equal to 230 at negative 120 degrees. And then finally yung ating VCN is equal to 230 at 120 degrees. Okay? So, i-apply natin itong mga formula na to para makuha natin yung line-to-line voltages. Pero para magamit natin yan, kailangan muna natin i-convert itong bawat isang to into rectangular form. So, itong VAN, pag kinonvert natin yan sa rectangular form, magiging 230 plus J0. Okay? And then, yung VBN naman, pag kinonvert natin yan sa rectangular form, is magiging negative 115 minus J 199.19. And then finally, itong VCN natin, pag kinonvert natin yan sa rectangular form, 115 plus J 199.19. So, pwede na natin i-apply ngayon itong rectangular form dun sa ating formula. So let's say VAN or VAB rather is equal to VAN, which is 230 plus J0 minus quantity VBN, which is negative 115 minus J 199.19. Okay? So, evaluate natin yan. So, magiging 230 plus, or tanggalin na natin yung parenthesis. So, gawin na lang natin yan 230 plus J0, and then distribute yung sign, plus 115 plus J 199.19. Okay? So, evaluate pa natin. 230 plus 115 is 345 plus J 199.19. Okay, so meron na tayong VAB in rectangular form. So kukunin natin yung polar form yan. Pag kinonvert natin yung sa polar form, magiging 398.37 with an angle of 30 degrees. So, ayan yung ating VAB. So, kung makikita natin, yung angle ng ating VAB is 30 degrees sa ating calculation, which is tugma doon sa ating angle sa phasor diagram. Okay? So, next is yung ating BBC. So, BBC is equal to BBN which is negative 115 minus J 199.19 minus ang ating BCN. BCN is at negative 115 plus J 199.19. Okay? So, evaluate uli natin yan is magiging negative 115 minus J 199.19. Then, distribute mo na naman yung sign, magiging plus 115 minus J 199.19. Okay? So, mangyayari dyan, magka-cancel out yung dalawang 115. Ang matitira is yung dalawang 199.19. So, 0 minus J 398.38. Okay? So, pagka convert uli natin yan into polar form is 398.38 with an angle of negative 90 degrees. So, yung ating BBC is 398.38 with an angle of negative 90. So, ayun yung nasa ating phasor diagram. Negative 90. Okay? And then, lastly, yung ating VCA is equal to VCN minus VAN, which is equal to VCN is negative 115 plus J 199.19. So, negative 115 plus J 199.19 minus ang ating VAN is equal to 230 plus J 0 is equal to negative 115 plus J 199.19 minus 230 minus J 0. So, ito is magiging negative 345 and then plus J 199.19. Okay? So, and then last step is ko-convert natin yan into polar. Magiging 398.37 with an angle of 150 degrees. So, ayun yung angle na yon, yung sa BCA, 150 degrees. So, tama yung ating phasor diagrams, tsaka yung, yung ating result using complex number. Okay? So, kung i-divide natin itong value ng ating line-to-line voltage, so line-to-line voltage and phase voltage is equal to 398.37 divided by 230. Lalabas dyan is 1.732 or equal to square root of 3. So, yun yung factor na square root of 3 dun sa formula. Okay? So, ayun yung ating example ng calculation ng line-to-line voltage from the phase voltages in Y-connected system. So, let's now go to our delta-connected systems. So, sa delta-connected systems, ang ating line-to-line voltage is equal to phase voltage. At yung ating line current is equal to square root of 3 phase current and lagging by negative 30. So, ayan yung ating relationships ng mga line-to-line and phase values sa delta-connected systems. Okay? So, dahil equal naman yung line-to-line voltage sa phase voltage, ang ika-calculate na lang natin or i-determine natin is yung line current from phase currents. So, para makuha natin yung equation ng line currents, IA, IB, and IC from phase currents, so, gagamitin natin yung Kirchhoff's current law. So, sa Kirchhoff's current law, ang sinasabi is, the sum of the currents entering the node is equal to the sum of the currents leaving the node. So, kung i-apply natin yung KCL sa node A, so, yung mga currents na pumapasok sa node A is IA and yung ICA. So, plus ICA is equal to the sum of the currents leaving the node, which is yung IAB lang. IAB. So, para makuha natin yung IA, itatranspose natin itong ICA sa kabilang side of the equation. So, magiging IAB minus ICA. IAB minus ICA. Okay? So, ayan yung ating equation para sa line current IA. And then, para makuha naman natin yung IB, i-apply din natin yung ating KCL sa node B. So, yung currents entering node B is IB. So, IB and IAB. So, plus IAB is equal to the current leaving the node, which is IBC. Okay? So, same thing, para makuha natin yung IB, transpose natin tong IAB sa kabilang side of the equation. So, magiging IB is equal to IBC yan. So, IBC minus IAB. Okay? So, yan yung ating equation para sa IB. And then, lastly, para naman sa IC, so, i-apply na naman natin yung ating KCL sa node C naman. So, ang currents entering node C is IC and IBC. So, IC plus IBC is equal to currents leaving the node, which is ICA. ICA. So, para makuha yung IC, ma-transpose ito sa kabilang side. So, ICA minus IBC. So, yan yung equation na gagamitin natin na basihan sa pag-construct ng ating phasor diagram. At yan din yung gagamitin nating equation sa pag-calculate ng mga line currents using complex numbers. Okay? So, katulad nung sa Y-connected systems, ang ating line currents is equal in magnitude but separated by 120 degrees sa balanced delta systems. So, kung ang ating gagamiting reference is yung IA or yung IAB rather, so gagamitin natin yung IAB as reference. So, ilalagay natin yan sa 0. Ito yung ating IAB at 0 degrees. So, yung ating IBC sa positive phase sequence, ang ating IBC is i-denote din natin ng yellow yan para ma-distinguish natin yung mga currents. So, ito yung ating IBC at negative 120 degrees. Okay? And then, finally, yung ating ICA is banda rito yan. So, ICA at 120 degrees. So, katulad lang din yan nung kanina. So, ito is 120 degrees apart. At ito naman is 120 degrees apart. Okay? So, para makuha natin itong IA, is gagamitin natin itong equation na to. IAB minus ICA. So, IAB yung ating reference sa phase current minus ICA. So, ICA is ito. So, dahil minus yan, katulad ng ginawa natin kanina, so, idudugtong natin yan dun sa ating reference IAB, pero with the opposite direction. Okay? So, ito yung direction yan ngayon. Yung arrow is papunta doon. And then, yung ating IA is yung phasor from the tail of the first phasor to the head of the last or the second phasor. So, more or less nandyan yan. So, okay. So, dahil ang ating relationship is yung IL daw is lagging by negative 30 by 30 degrees. So, lagging. So, negative 30. Kung yung ating reference is 0, so minus 30. Okay, so ito yung ating IA. IA at negative 30 degrees. Okay, so para makuha naman natin yung IB, ganun pa rin yung gagawin natin. IBC, so ito naman ang reference natin, IBC minus IAB. So yung IAB is itong red, pero dahil negative sign, papunta doon. So kunin natin yan. Copy natin yan. So copy natin yan and then lalagay natin dito. Okay? Pero dahil negative yung direction, yung arrow niyan is nandito. Okay? So yung ating IB is yung resultant phasor from tail of the first to head of the second. Okay? So yan yung ating IB. At negative 150 degrees. Dahil yung ating reference is at negative 120 minus 30, so negative 150. Okay? So ito is, ano natin yan dyan. Ito is negative 150 degrees. And then lastly, yung ating IC is equal to ICA minus IBC. So ang reference natin is yung ICA minus IBC. So kukunin natin yung IBC, i-copy and paste. Pero ang direction niya is pabalik. Okay? Opposite direction. Okay? So ayan yung ating negative IBC. So ang magiging resultant phasor niyan is from tail to head. From tail to head. So pag ganon. Okay? So ayan yung ating IC, which is at 90 degrees. Kasi ito is 120. Kung ito ay 120 minus 30, so ito is 90 degrees. So ayan yung ating phasor diagram. Okay? So mag-solve tayo ng isang example using complex number para makita natin yung calculation ng ating line currents using phase currents. At makikita rin natin na consistent yung maging result natin dito sa ating phasor diagram. So let's say for example, meron tayong phase currents IAB which is equal to 10 at 0 degrees, and then IBC is equal to 10 at negative 120 degrees, and then yung lastly yung ating ICA is equal to 10 at 120 degrees. So katulad ng ginawa natin kanina sa Y-connected systems, i-convert muna natin yung bawat isa na yan sa rectangular form. So ito, pag kinonvert natin sa rectangular, magiging 10 plus J0. Itong IBC, pag kinonvert natin sa rectangular, is magiging negative 5 minus J 8.66. And then lastly, yung ating ICA, pag kinonvert natin sa rectangular form, is magiging negative 5 plus J 8.66. So ngayon, makakalculate na natin yung ating IA is equal to IAB, which is 10 plus J0, 10 plus J0 minus ICA. Yung ating ICA is negative 5 plus J 8.66. Okay, is equal to 10 plus J0 plus 5 minus J 8.66. Okay, so ang lalabas dyan is 10 plus 5 is 15 minus J 8.66. Okay, so convert natin yan sa polar, magiging 17.32 at the angle is negative 30 degrees. So ito, IA is at negative 30 degrees. Makikita natin dyan. So yung ating IA is at negative 30 degrees sa ating phasor. Okay? So itong 17.32 is equal to square root of 3 times nung phase current natin. Okay? So, gawin din natin yan sa ating IB. Ang ating IB naman, ang equation natin sa IB ay IBC minus IAB. So, ang ating IBC is negative 5 minus J 8.66 minus IAB. Yung ating IAB is 10 plus J0. Okay? So, ang lalabas siya pag in-evaluate natin is negative 5 minus J 8.66 minus 10 minus J0. So, evaluate natin, negative 5 minus 10, negative 15 minus J 8.66. Okay, so same thing, convert natin sa polar, magiging 17.32 at sees of angle negative 150 degrees. So yung ating IAB is at negative 150 degrees. Tingnan natin yung ating phasor, IAB is at negative 150 degrees. Okay? And then lastly, yung ating IC is equal to, yung ating equation ng IC is equal to ICA minus IBC. So, ang ating ICA is negative 5 plus J 8.66. So, negative 5 plus J 8.66 minus quantity ICA is IBC is negative 5 minus J 8.66. Okay, so medyo pangit yung ating sulat, baguhin natin, negative. Okay, so is equal to negative 5 plus J 8.66 plus 5 and then plus J 8.66. Okay, so equals, so magka-cancel out yung ating 5, so magiging 0 plus dalawang 8.66 is 17.32 J. So convert natin yan sa polar form, magiging 17.32 sees of 90 degrees. So yung ating IC is at 90 degrees daw. Check natin yung ating phasor, IC is at 90 degrees. Okay? So ang magnitude ng ating line currents is 17.32 and then yung ating phase currents is 10. So same thing, pag dinivide natin yung ating line current divided by phase current is equal to 17.32 over 10 equal to 1.732, which is equal to square root of 3. So ayun yung factor na square root of 3 sa ating formula na IL is equal to square root of 3 I phase. And then napakita natin na yung ating mga line currents is laging trailing by 30 degrees sa I phase. So itong complex power calculation is pwedeng hindi na natin i-perform ito kapag balance 3-phase tayo dahil meron naman tayong shortcut na formula. Pero kapag ka-unbalanced na yung ating system, hindi na natin pwedeng gamitin itong shortcut formula na to, which is applicable lang to sa mga balance. So ang gagawin natin para ma-determine natin yung mga line-to-line voltage from phase voltage sa ating Y or yung line currents from phase currents sa ating delta, gagamitin natin itong complex number. Kaya importanteng matutunan din natin paano tayo mag-calculate using complex number. Okay? So, ayun lang po yung ating video sa araw na ito at sana may natutunan na naman kayo. At maraming salamat po ulit sa mga subscribers natin na patuloy na sumusuporta. At yung mga hindi pa po nakasubscribe ay iniimbitahan ko na rin po kayo na mag-subscribe na po sa ating channel. Paki-click na nyo na rin po yung like and notification bell at i-share nyo na rin po. Maraming salamat po at God bless po sa inyong lahat.